Hello teachers, well you are students right now, right? So let's discuss about what happens with students. Most of our students who are with us, we allegedly say that we work with their brain. We help them enhance the brain, we help them learn and develop skills and so on and so forth. However, we also know that they are with us, they are our captive audience, they are with us for a longer period of time as compared to any small window that we get in any other medium of learning. Especially in the classroom, what happens is that our students are with us at least for a semester or at least for a year, one academic year to make it the shortest. So, what do we do in this one whole year with our students? What is it that we work with? Do we work with their hearts, their minds, their social environment, the culture that they bring in, their emotions, is something that we need to really ponder about. To introspect that as a teacher, which aspect of my learner am I focusing on? Am I actually looking at a holistic development of my student, or am I focusing on one appendage growing? All this that we think about, that we need to really mull over, we need to really give enough time to understand our own style of teaching, and when we are teaching, how we are teaching, what is the theory behind it, what is the theoretical premise that we work on. It's almost like a chassis. The theoretical premise that we work on is like a chassis on which our car is built or on which the vehicle is built. What we bring to the classroom, those little activities, those little fun items, the patterns that we bring in, the stories that we bring in, the assessments that we do are based on this chassis or this theoretical premise that we build our teaching on. So, what is this theoretical premise that we build on? There are various theories, as all of you know. Theories of learning are abundant. The number of experiments done, the number of studies done, surveys done, pilot work done is really humongous. The corpus that we have in front of us is huge. Today we will pull out one of those pieces. What we will bring today to our session is what happens with the brain. All of you would agree that we learn with our brain, right? And this is the brain is one big mystery. It's something that sits in its own place, properly covered, very well protected, and we really do not understand well what happens in that, what kind of stimulus does it respond to, how it responds to certain stimuli, why it does so, and as teachers, for us to understand that becomes very critical. You may ask me, why is it important? I mean, I bring beautiful activities to the classroom. People before me have done it. They have shown that it has got great results. So why can't I just do that? Why do I invent the wheel? Well, no, we are not inventing the wheel. We are actually trying to understand what happens behind the screen. It's like watching a play. When we watch a play, we see that these actors are, like little puppets doing their bit on the stage. We go through various emotions that they make us go through. We go through various feelings, we laugh with them, we cry with them. We go through the complete narrative, the complete story. But do we really know what happens behind the screen? What efforts these actors have put in, what effort the writer has put in, why the writer has brought out a particular topic, what is it they're trying to do, how does the writer and the actor and the director know which emotion to trigger, what to say in order to trigger a particular response. This is exactly what we want to do today. We want to understand what happens in the brain. How does the brain actually learn? Or does the brain learn at all? Or is it just a series of reflex actions? Is it just a series of, you give a stimulus and you react to that or you respond to that? It's like, hitting your knee with a hammer to get that reflex action, as most doctors do. When you go in and you say that, okay, I have a knee which is not working, or I'm not able to really feel, there are no sensations, then there's a little hammer that they use which they hit on the knee. And the knee, if it is really functioning, will automatically respond or react. What happens? The knee which is in this shape will suddenly go like this. Similarly, does the brain do that? Does the brain actually just live on reacting to a stimulus? I don't think so. And it's not me who is saying that. It's a lot of research that has gone in. Neuroscientists have worked on this. Educationists have brought that into the classroom. They have worked with students, with learners, starting from the primary level to the adult learners level. Well, the human brain consists of three parts, the cerebellum, the stem and the cerebrum. It's actually in the cerebrum that the learning happens. That is the most active part and a very powerful part, where higher order learning happens, where higher order skills are developed. Without going too much into it, I'll walk you through very quickly through the physiology of the brain and how the learning happens in the brain. What happens is that the human brain consists of special cells called neurons. Now, these special cells called neurons are composed of several parts. One of those, called brain fibers, are known as dendrites. What happens to these brain fibers? As we learn, as our learning increases, these brain fibers grow. These brain fibers actually connect our brain cells to one another at certain contact points called synapses. These brain fibers keep becoming thicker and thicker as the learning increases. To give you a very quick parallel, you would notice that evolution, as it has happened, when evolution happens, how the beings have evolved, the part of the body that is most used becomes stronger, becomes more powerful, becomes well defined, right? So you might have heard of, as we see in sci-fis, the Martian brain is much larger than the brain of the human beings on Earth, right? Why is it depicted in sci-fis like that? Because the Martians use their brain much more than the other limbs. Something similar happens in the human brain. The brain fibers become thicker as they get used more often. So the brain keeps building on this. What really happens? They can only grow. So if for example, you find a brain which doesn't have fibers at all, these fibers or these dendrites at all, then it cannot learn. Okay, it's a dead brain. So the learning happens from existing prior knowledge. It's not as if it's a tabula rasa, there is absolutely no knowledge and suddenly learning has started. It doesn't happen like that. There is something existing and based on that a new learning happens. And when this new learning is reinforced, the frequency keeps increasing, that is, it is practiced again and again, then these fibers become thicker and the learning becomes enhanced, the learning becomes more in depth. So, you would notice therefore that, people who have information about a whole lot of things, like 2000 and other odd stuff, they have shallow peripheral level information. But when you get into deeper research, then you may not be focused on the peripheral learning, but you are focused on in-depth learning, meaning that your learning in that particular area becomes stronger and stronger and more in-depth. How does that happen, or how is that visualized in the brain? The dendrites or the fibers have become thicker around that particular knowledge center. This is what happens inside the brain when learning takes place. So, in order to learn something new, what do? An individual or a learner or your students will be building on information already available in the brain. We have noticed that education is said to be streamlined. The syllabus, quote unquote, the syllabus is the same across social strata, across economic strata, across cultural barriers. This is what we say. Then why is it that we find that certain groups of people or students do not learn the same information in the same way. So if you take a case study or if you take a sample students from various cultural milieu and then you give them the same learning item, you find that each one of them learns it differently, interprets it differently, and we are surprised. We say the facts are in front of you. Why do you interpret it differently? Well, that's because the brains of each of these student group has certain prior knowledge. And that prior knowledge is very, very specific to their social strata, their cultural milieu, the kind of cultural construct they live in, and therefore their interpretation is different. So the brain actually learns in this particular manner. So what happens is that, as we see, when we practice a certain skill that we have picked up or a certain knowledge that we have learned, then with practice these dendrites or these fibers start thickening. How do they become thicker? With regular practice, these dendrites coat themselves with a fatty layer, very unlike the fat that we otherwise develop and want to keep reducing or removing. This fatty layer is a positive fatty layer. As this coat keeps getting thicker, our connections become stronger, that is, the connections of these dendrites become stronger, and therefore any specific information or an ability or a skill, we become more and more successful in that particular skill. We become more and more adept in that particular skill. For example, that is precisely why we say that this person has 10 years of experience, 20 years of experience, and therefore knows everything. And one of my professors, if I could share this with you guys, I really hold him in very high esteem, would walk into the classroom with nothing in hand. We carry our chart papers, we carry PowerPoint, we carry activity sheets, whatnot. But this gentleman would walk into the classroom with nothing in hand. And every session was scintillating, full of learning. Why was that? It's because his experience in that field was so strong, so powerful, and he had solidified his skills so well, be it from a knowledge perspective, be it from a classroom practice perspective. So as teachers, it's important for us to understand that while we, bring in practice into the classroom so that our students make stronger connections, while we bring in practice into the classroom so that we solidify the information that we have given to our students, so that whatever information has got into the brain becomes permanently ensconced there. It's like, my phonetics professor used to say that, even if you are dead drunk and you're passed out and somebody slaps you and you wake up, you speak with the correct pronunciation, what we used to call RP, or the received pronunciation, as most of you who teach English would know. Why would that happen? Because the practice is so strong. The repetition has been so often done that the learning, the skill has stayed in the brain. So even when one is not in one's senses, one speaks in the right or the correct pronunciation. You can always, extrapolate that to any learning. My dad used to say that, even if you are fast asleep and you wake up and I give you a mathematical problem, the solution should just come to you like that. It's almost like a reflex action. Very much like when we drive, when we take a particular route day in, day out, after some time, we don't really look at whether I have taken the right left turn or the correct right turn, or I have got the right landmark, right? What happens then? We do it, by just reflex. It's not that it's something that it's a great miracle. It's because we have done it so often, we have practiced it so often that it is almost part of our system. And that's what happens. So we want to make a particular learning for our students stay with them all their life. Then we need to give them more practice. This is another way. This is the way the brain learns. Okay, and so the question from all you teachers would be, So whatever happens in the background happens. Why do I need to understand that? What is it that I'm going to gain out of it? As I said very early in our conversation, that you take the parallel of a stage performance. It's very important to understand what happens behind the screen, so that I'm able to do better what I am doing in front of the screen. So parallelly, that means that if I understand how the brain learns, I understand, as a teacher, I'm able to know the mechanics of the brain, how the brain functions, what are the different things the brain reacts to positively, what are the different things the brain reacts to negatively. Then what can I do? I can actually make use of that to create an environment in my classroom for my students, to create a methodology to teach better, to design my lessons in such a way that the learning is faster and the learning is retainable, right? Therefore, it's important as teachers for us to understand and know what is brain-based learning or how the brain learns, right? Very simple parallel or an anomaly that I can give you is that grammar. So I'm a teacher of English, and I remember that when I go to do train the trainer, or what is called faculty development programs for teachers who do teaching, that is, who teach English, they ask, why do I need to know formal grammar? I don't teach formal grammar. My answer is that it's not that you teach formal grammar. It is not that you are actually teaching the definition of grammar, the various aspects of grammar to students. You are teaching them what is called functional grammar. But in order to teach that, in order to explain, in order to let people know why, a simple example of why a for works and a to doesn't work in the preposition format in a particular sentence, one needs to know formal grammar. Similarly, as teachers, it's important for us to understand what happens in the brain, what is pro-learning, what is not pro-learning, what really kind of hinders learning, or what actually enhances learning or motivates learning. Therefore, the whole process or a whole theory called brain-based learning has come up. So the question is, what is brain-based learning? Brain-based learning is nothing but, teaching methods or lesson designs, school programs that are based on scientific research about how the brain learns. It talks about cognitive development that happens and the factors that lead to cognitive development. So that means how students learn differently as they grow, as they age, as they get exposed to different social environments. They become more mature emotionally, they become more mature cognitively. In order to be able to create, that is design appropriate, that is learner appropriate lessons or programs, in order to follow a methodology, a teaching methodology which is appropriate to our audience. That means whether we are dealing with pre-primary students, we are dealing with primary students, secondary or higher secondary students, tertiary level students, whether we are into pedagogy or andragogy, that is whether our learners are children or our learners are adults, we need to know this in order to make our process more effective. We may be efficient teachers, but are we effective teachers? The difference is very thin. I do great work, I perform really well, I have classroom presence, I keep my students enthralled for that 1 hour or 2 hours that I spend with them. I'm very efficient. I've brought in all the required tools to the classroom. But am I effective? And by that what I mean is, have I actually been successful in making my students learn? I have taught. I have done a great job of it. But have my students actually learned? And by learning I mean, have they understood the knowledge? Have they taken in the information? Have they built the skills required? And will they be able to practice it outside this classroom environment? This is something that we need to keep in mind. And therefore, to understand brain-based learning, we need to go ahead from here to see what all is involved in brain-based learning. So, the strategies, purposeful strategies that we use on principles derived from solid scientific research. One of the key scientists who has worked on brain-based learning is Eric Jensen, and as we go further, we will talk in depth about most of these theorists who have worked on brain-based learning. But we need to keep in mind that we are looking at brain-based education, where we will be looking at strategies that we can use based on the principles that we have derived from scientific research on how the brain functions and how the brain learns. One of the core principles is that the brain is a parallel processor, which means the brain does not learn in a linear fashion. It does not perceive one thing at a time. It perceives multiple things. It processes parallel things at a time. That means it takes in wholes and parts simultaneously. It does not just perceive in a linear fashion. Information, therefore, that is stored in multiple areas of the brain come together and then are engaged in the learning process. So, for example, let us say that we are in the classroom and we share a particular sentence structure. I'll give you a quick example. My niece, when she was learning, when she started acquiring language, my mother tongue is Odia, so she first learned Odia. And how did she build her pattern of sentence structure? She started off by saying to me, give it to me. And then, because that was the structure, give it to me, give it to him, give it to somebody, the structure that she picked up to someone, she then replicated that in other sentence structures. So, the to preposition became a fixture in every sentence that she occurred. How did that happen? That happened because her mind, in her brain, she already had that preposition to. And in English, it's a preposition, but in Odia, it's actually a postposition. So, she would not say, for example, I'll use that sentence over here, give that pen to me. So, in Odia, we would say, motte sei penta dio. But she would immediately turn it and say, motte ku, which means to me, you turn it upside down, me to, the postposition. Why did she do that? The question is that she built it from her earlier repertoire. She already had it in her mind. So, when she started learning this sentence, she brought in that information also and she put it together in the sentence. She continued to speak like that for close to 5-6 years till she matured in the social environment where she heard others speak and she realized that there are two types of sentence structures. So, the brain therefore is a parallel processor. It processes multiple things at the same time. It takes in information stored in other areas of the brain, brings it to the forefront and then works with this multiple memory to learn new subjects or new knowledge. Another core principle is that the brain is continuously and constantly searching for meaning. The brain is actually a meaning-making machine. Anything that happens, the brain wants to make meaning out of it. What happens therefore is that there is a patterning process. So, for example, the behavioral learning model that we talked about. What happens in behavioral modeling is that we give a stimulus and depending on the way the subject or the learner responds, there is a reward or there is a punishment. What does the brain do? It does not stay with that. The brain creates that pattern. right? And the pattern that the brain creates, the brain starts creating, adding a meaning to it. This patterning helps in building learning. So, for example, our emotions. Our emotions play a very, very powerful role in creating this patterning. So, how we feel about a certain behavior, how we feel about a certain information, that helps us to drive our attention towards that pattern or move our attention away from it. For example, with me, I react very, very negatively towards tragedy. So, in my mind, the emotion that I immediately build is that if there is something tragic, I build an emotion of sorrow, pain, anger, right? And therefore, this pattern has been built across time. And with me being as old as I am, I drive my attention away from anything that is tragic. I have made a meaning out of these memories. So, if I am learning, and if I really want to learn the best way with positive input sharing, then I will learn best if there is a lot of positive stimulus given to me. So, as I said, the environment that we create in a learning situation for our students lead to the kind of emotions it triggers. We all have heard of various environments. I mean, this is a story that I really like to share. My very beginning, I think I must have been all of 4. And my mom, not being really highly educated, saw my neighbors' children, actually going for tuition. She said even before starting the school, one evening she gave me this little board and a slate, the slate and a piece of chalk, and she said, go, that sir sitting over there, he teaches all the other kids, you go and you also start learning, without any premise creation, without any idea. So what did I do? I also walked like an obedient child that I was, and I walked in. When I walked in and I stood at the door and I heard one of those kids, screaming in pain, and I noticed that the tutor was actually, he had a scale in hand, and he had asked them to, form a fist, and he was hitting their knuckles because they had not done the homework the previous day. All I did was took an about turn and ran home, and that was the end of my ever going for a tuition. Look at the kind of negative environment that person had created, the teacher had created, and the emotions it triggered. So much so that till this day, any kind of punishment and I rebel. Anything which is authority, I rebel. How did this happen? An emotion, a very negative emotion was created, and I don't learn under such emotions, under such environments. What is therefore very important is that the brain, each brain reacts differently. And as far as possible, a positive environment, a positive emotion trigger leads to faster and quicker learning and more retainable learning. One of the other core principles of brain-based learning is that we need to keep in mind we have 2 types of memories, because we learn through memory, to be very frank. So, one of the memory is that it's a spatial memory, and the other is a rote memory. Most of the time we face problem because we focus on the rote memory. That is, we memorize in the sense we repeat again and again and again, and we learn by that repetition. There is a difference between repetition and practice. And when we practice, we actually nurture the spatial memory. And therefore, when learning or when information is embedded in a spatial environment, in a more hands-on, in a more practicable situation, it triggers natural memory, naturally spatial memory, and therefore learning is much better over there, vis-a-vis the rote memory. I'm not saying that rote memory is absolutely obsolete. It works. For example, you want to learn the tables or you want to learn certain formula. Therefore, it really works. I think the memory helps you, the rote memory or rote learning helps us to keep this particular piece of information or knowledge with us. But what's important is how often do we practice, do we put it into practical use, and do we give our students that kind of a learning environment. Have we designed our content? Have we designed our learning in such a way that our students get practice again and again? A very interesting part is that the brain is very social. The brain learns better in a group. Why is it that the brain learns better in a group? Because if we are in a group, then we take information from each other. We take learning from each other. We practice together. We are able to throw up a theory and listen to another person respond to it. We work in such a way that the brain's social aspect gets enhanced, gets triggered, and therefore this learning stays for a longer period and we are able to put it into practice much faster in a better way, right? Another thing that we have noticed is when we are challenged, okay, when we are challenged in the sense that we are able to stretch our capabilities, stretch our abilities a little more than where we are. So, in a classroom environment, when the brain is challenged to do things it has not done before, but is finding it interesting, then learning gets enhanced. However, if we create a negative environment of high stress, you have an exam, you need to score so much mark, you need to, reach a particular, your destination, which being scoring so many percentage, whatever that percentage is, or doing better than the next person, or getting into a competitive examination and scoring so much, getting into a particular business school or moving for higher studies and so on and so forth, which becomes an extremely stressful environment. The brain, which is always pro learning, there is no brain that cannot learn, gets inhibited by this stress. And when it gets inhibited by this stress, it stops learning. Nowadays we find, we hear extremely sad, tragic stories of, students who take extreme steps because they have not been able to meet certain expectations, or they have not scored as much as they were expected to score. They did not get into a particular business school or a particular Ivy League space. It is very sad, because learning needs to be a playful process. The brain becomes more and more active, becomes extremely powerful and involved when there is a playful, there is a non-threatening and a safe environment created for it. So these are some of the brain-based learning principles, core principles that we have discussed with you. We need to keep this in mind as we move further in our next session to discuss about various theorists and how they have done experiments to bring in these core principles and have they used it in education. Thank you.